Okay, we're going to look here at a C4 problem. This is a problem actually from the problem sheet right here. A 332 Mako shark is moving in the positive direction at a constant velocity of 2.3 meters per second along the bottom of the sea when it encounters a lost 19.5 kilogram scuba tank. Think the tank's a meal. It has lunch. Assuming the momentum is conserved in the collision, what is the velocity of the shark immediately after it swallows the tank? So in a problem like this, we're using the conservation of momentum. Remember, the conservation of momentum has a big equation, but it's really not bad. M1 VI1 plus M2 VI2 equals M1 VF1 plus M2 VF2. So that's the equation we're using here. Nothing too crazy. In this problem, we know that our M1 here is our 332 kilogram Mako shark. We know it is moving at 2.3 meters per second along the sea floor. We know that the scuba tank in this problem is 19.5 kilograms and its initial velocity is a whopping 0 because it's at rest on the sea floor, so that's actually going to be nice. It's going to remove all of this. And then that's going to be equal to the mass of the Mako shark, the 332 kilograms, times some unknown final velocity plus the mass of the scuba tank, 19.5, times its unknown final velocity. Now in a problem like this where you have the shark eating the tank as a tasty meal, so if you look at that problem again, it has lunch, so the shark eats this scuba tank. So the scuba tank is now inside the shark. What this means is that the shark and the scuba tank are now moving together. So this final velocity of the shark and the final velocity of the scuba tank are actually the same quantity. These are like terms if we were to use kind of our mathematical reference. And since those are like terms, we can add them together. So if we kind of work out this problem starting with the left side here, this 332 times 2.3 is going to give us 763.6 Newton seconds plus 0, so we're just equals, and 332 plus 19.5, because I can add these terms together. That's going to give us 351.5 times the final velocity of the shark scuba combo. If we play a little bit of division here at this point, divide by 351.5, divide by 351.5, that's actually kilograms by the way, we end up getting 763.6 divided by 351.5. That gives us a final velocity here for our shark scuba tank combo of 2.17 meters per second. So we see that the shark has slowed down a little bit. If we look at our beginning velocity of the shark to our final velocity of the shark, it has slowed down a little bit. It gained some mass whenever it ate the tank. Nothing crazy there, kind of expected. And the tank is now naturally moving inside the shark. So that's what we get for a C4 problem where we are keeping objects together in an inelastic collision. We see that the masses get to add together at the end here. So with that, that problem is over. Not too bad.